So the big picture for this lesson is about real numbers and inequalities and also intervals. Now an interval is all related to a number line. So here's just a basic number line. And this, for example, plot a point at 1 and another one at 2 and another one at 3. So what if we just wanted to talk about if we wanted to talk about these numbers individually, it's very easy. We have 1, 2, 3. But what if we want to talk about all the numbers between 1 and 3? Well, we could say 1.5 is between 1 and 3. We could say 2.2 is between 2 and 3. We could say 2 3/4. And we could keep listing numbers on and on forever. But we could never actually list all of the numbers between 1 and 3. So what we need to talk about is an interval. An interval is a subset of numbers, but in this case we're talking about a continuous subset, all the numbers between 1 and 3. So if we want to write an inequality for that, we would just do something like this. We would have 1 as the lower bound, and then I guess we should define this as x for the values on the number line. So we'd say x is greater than or equal to 1 and less than or equal to 3, like that. Okay, that's our inequality interval. There's also an interval notation, and that looks a little different. So let's say, for example, we're including all the numbers between 1 and 3 and 1 and 3, just like we have in this inequality. So interval notation, square bracket 1, comma 3. This is saying the exact same thing as the inequality, all the numbers between 1 and 3 and including 1 and 3. Now this is called a closed interval because it includes both endpoints of the interval. So this is closed. It is also called a bounded interval because there are ends to the interval. In other words, it doesn't go on forever in either direction. It stops at 3 and stops at 1. Let's look at another example. Okay, now for this situation, we're going to go back to the 1 and 3, but this time, let's say we're not going to include the 1. So I'm going to put an open circle around the 1, but we are going to include the 3, so that's going to be a closed circle. And then we're talking about the interval between those two values. So for an interval, it would be x is greater than 1 and less than or equal to 3, because the 1 is not included, but the 3 is. So to write an interval, we would use a rounded bracket, 1, comma 3, and a closed bracket. Now this means the 1 is not included, but the 3 is. And we could simply say this is half open, and it is also bounded. Now it's half open because you have an open interval on one side. An interval is only closed if it is closed on both sides. And then bounded because it doesn't go on forever in either direction. Now let me show you an example of unbounded. Okay, so we'll start with 1, and you know what, let's include 1 this time. We'll put a closed circle. And then we're going to have it continue, let's have it go this way. So what we're saying here is our interval is including 1 and all the numbers less than 1. So you could say x is less than or equal to -1 as an inequality. For an interval, it would look like this. You'd have the 1 here, and it's closed because the 1's included, but it would continue to the left forever. Okay, so this is not a bounded interval because it goes forever to the left. It doesn't stop. There's no end. But there is a bound on the right because it stops at 1. So this one is half open, and also unbounded. Now, you don't have to get real technical here. Usually, you want to talk about whether an interval is just open or closed. I mean, half open is kind of overly detailed. So if you just wanted to call this an open interval, that would be totally fine too. The point is, it's either closed or open. You could also say it's closed with respect to the 1, but open with respect to negative infinity. But you're never going to have a closed with negative infinity because infinity goes on forever. It's not a number, it's an idea that the numbers don't stop. So just one more little example here. Let's say if I wanted to look at an interval like this, 1, 3, it would be closed with respect to the 1, but open with respect to the 3. You could read it that way. Okay, so that's a big picture for the lesson. I hope this has been helpful for you. Okay, so that's the big picture for this lesson.